Okay guys, good day. Our topic is radial groundwater flow in confined aquifer. Where your Q in here is the flow rate in your pumped well and R is the distance of your observation well to your pumped well. This is the comparison of your confined aquifer and unconfined aquifer. And then in this illustration, this is your unconfined aquifer and this is your confined aquifer. Q is equals to 2 pi xm kf dy dx, where your 2 pi xm is the area through any cylindrical shell. Kf is the hydraulic conductivity. Your dy dx is the water table gradient at any distance x, and the Q is the well discharge. This is where you're going to find your x, and this is your m, or the aquifer thickness. Integrating, this is the formula, but we're going to equate that with our Kf, which is the coefficient of permeability, which is equals now to 528 Q log of R2 over R1 all over M times H2 minus H1. This formula is only applicable if your Q is in gallons per minute and your Kf is in gallons per day per feet squared. Uh, this is your R1, which is the distance between your pump well and your first observation well. Your R2 is the distance between your second observation well to your pump well. So we have a sample problem. Determine the permeability of an artesian aquifer being pumped by a fully penetrating well. The aquifer is 90 feet thick and composed of medium sand. The steady-state pumping rate is 850 gallons per minute. The drawdown of an observation well na 50 feet away is 10 feet, and in a second observation well na 500 feet away, the drawdown is 1 feet. So, ang given, R1 50 feet, R2 500 feet, M 90 feet, ang H1 and H2, why may X? Because ang ating na distance there is unknown. So, we're just going to label that as X. In order for us to find H1 and H2, ang X, minusan ta sang aton nga drawdown nga S1 and S2 plus ang 90 nga distance or thickness of our aquifer. Required is Kf na. And then, substitute sa aton formula, Kf now is equals to 528 times 850 log of 500 over 50 all over 90 times x plus 89, which is your H1, minus, open and close parenthesis, ang imo nga H1 nga x plus 80. Distribute the negative sign, ma-cancel out ang x dalong, leaving us with 89 over minus 80 na lang, that is dalong mo. Solve this, ang Kf will give us a value of 554.074 gallons per day per feet squared. So recap again, this formula, ang Kf, is only applicable if aton Q is gallons per minute, and our Kf is gallons per day per feet squared. So what if ang aton Kf and Q have different units? So just convert. Like for example, our Kf were given in feet per second. Ang feet per second, convert siya danay sa feet per day. And then, convert to GPD per feet squared. And then, amo na aton i-substitute nito sa aton nga formula. So, what if naman ang flow rate? If aton nga flow rate given is feet cube per second, ang real, feet cube per second, convert siya danay sa m cube per day. And then, ang m cube per day, convert to GPM or gallons per minute. Kaya mo ng value nga, mabutang lang natin sa aton nga formula. I hope you guys may na-learn ka mo. Okay, thank you and God bless.
Radial groundwater flow in unconfined aquifer. A unconfined aquifer or water table is an aquifer whose upper water surface or water table is at atmospheric pressure and thus is able to rise and fall. Unconfined aquifers have special treatment because they are main groundwater charge locations, shallow and easy to reach by local settlers in cheap manner, and they also provide storage possibility for natural and artificial groundwater activities. Where groundwater is in direct contact with atmosphere through the open pore spaces of the overlying soil or rock, then the aquifer is said to be unconfined. The upper groundwater surface is an unconfined aquifer is called the water table. Unconfined aquifers are usually recharged by rain or steam water infiltrating directly through the overlying soil. Typical examples of unconfined aquifers include many areas of coastal sands and alluvial deposits in river valleys. Unconfined aquifer, unlike confined aquifers, are generally found located near the land surface and have no layers of clay or other impermeable geologic material above the water table, although they are found lying relatively above impermeable clay rock layers. The uppermost bound the uppermost boundary of groundwater within the unconfined aquifer is the water table. The groundwater in unconfined aquifer is more vulnerable to contamination from surface pollution as compared to that in confined aquifers. This being so due to easy groundwater infiltration by land pollutants. Unconfined aquifers have storative value greater than 0.01. Birch aquifers are special cases of unconfined aquifers occurring in situations where groundwater bodies are separated from their main groundwater source by relatively impermeable rock layers of small areal extends in zones of aeration above the main body of groundwater. From this diagram shows aquifers with one aquitard or a confining or impermeable layer between them, surrounded by the bedrock aquiclude which is in contact with the gaining stream, typical in humid regions. The water table and unsaturated zone are also illustrated. The solutions of radial flow to a well and unconfined aquifer is derived in an analogous manner to the derivation of radial flow solution for constant T aquifers. The resulting radially symmetric solution is H squared equals to Q pi K ln R plus C, where Q is the well discharge, C is a constant, and R is the radial distance from the center of the well to point, where H squared is evaluated. The discharge Q is where positive for wells that extract water from the aquifer and negative for wells that inject water. Thank you.
Hello, good afternoon. Our topic will be travel time of groundwater flow in confined aquifer. The time intervals between recharge and discharge points is defined as the travel time of groundwater. Travel time is used in several applications such as designing exploitation and monitoring systems, identifying areas affected by contaminate migration, and assessing the potential for natural attenuation of pollutants. So, amo ning ginagamit sang travel time para mabalaan na amo ni mga applications. So, as you can see here in the image, so once the precipitation occurs, the water will infiltrate into the ground, which becomes groundwater. So when the groundwater reach the water table, which the water is saturated, the ground the groundwater flows into direction in vertically or horizontally. So based on the image, the groundwater will flow going towards the stream, and the stream is where the discharge point. So the recharge point is when the when the water infiltrates into the ground. Okay, so the recharge point is when the water infiltrates, and the discharge point is when the water flows out into the stream. So analytical solutions to estimate the travel time of groundwater for confined aquifers with regional flow and other unconfined aquifer conditions by infiltration in oceanic islands and inland islands with both circular and strip morphology. The groundwater moves fast, about a velocity of 1 foot per day or greater is a high rate of movement for groundwater, and groundwater velocities can be as low as 1 foot per year or 1 foot per decade. So the equation for calculating groundwater velocity, so it's V equals to K times I over N, where V is stated as groundwater velocity and the K is horizontal hydraulic conductivity and the I is horizontal hydraulic gradient while the N is the effective porosity.